Hey folks, Mr. Dell here. We are looking at a problem that's a proof, and we are given the skeleton of this proof, and we need to fill in some of the blanks. So let's go through that process. So it's a two-column proof. So this is coming from CPM's Math Integrated Math 2, and this is section 7. Actually, it's closure is what this one is. So this is the closure chapter 7. And this is number 121. It says Kelly started the proof below to show that if TC, actually that I'll put the T over here, this if TC is congruent to TM and AT bisects angle CTM, then CA is congruent to MA. So there's our, when you see this if what? If these two things, those are the givens, then this is what we want to prove, right? So then we want to get to that as our proof. So we can see our shape, and just let's mark it up based on what we have here. So TC is congruent to TM. So TC, let me use a different color there. So TC is congruent to TM, and AT bisects, right? AT bisects this angle CTM. So remember, an angle bisector gives me equal angles. So that tells me that that and that, those two angles are equal because it bisects the angle. So let's see what we have. So TC is congruent to TM. Well, that right there is a given. And then the statement AT bisects angle CTM. Once again, right there it's written, that's also a given. Those are my reasons. So now we go to 3. What does it say? Definition of bisect, right? Well, so if I have my reason being definition of bisect, what I'm looking at is I'm thinking that we need to establish that these two angles here are congruent. So we would say angle CTA is congruent to angle MTA, right? So I just established, because I have an angle bisector, right? We just talked about that this angle is congruent to that angle. Those are congruent angles, right? So let me make it a little bigger. That angle is congruent to that angle because it's an angle bisector, and that's the definition of bisect. AT is congruent to AT is the next statement. Well, AT is congruent to AT, that's because it's the same side. So you can say same side, or the property we use is the reflexive property is what it's called. It's the reflexive property, or same side. Same sides are congruent. Then the fifth, let's see. Well, fifth is blank. So it's blank on both. So let's think through this. Well, we want to, if I go to the sixth one is saying congruent triangles mean congruent parts. So if I'm going right to that as my reason, then somewhere up here I need to show congruent triangles. So my statement up here is going to have to deal with congruent triangles. So what triangles now, based on what information I have, can I say that I've got some congruent triangles? So let's look. If I know that this is equal to that, CT is congruent to TM, and AT is congruent to itself, I established that those two angles are congruent. I have a side angle side. So we could say that triangle CTA is congruent to triangle MTA. Why? Because of side angle side triangle congruency. Side angle side triangle congruency. So now that I've got those congruent, I wanted CA is congruent to MA. If I have congruent triangles, I have congruent parts. That's my last reason. So I can go ahead and put my last statement that what I wanted is true. That CA here is congruent to MA because congruent triangles have congruent parts. All right, so there's my proof.